Welcome back to Statistical Reasoning. We are starting Chapter 6, which deals with normal probability distribution versus the discrete that we did in the last chapter. One of the things that we'll do when we're dealing with normal distribution is our shape is bell-shaped. We have a mean of 0 and a standard deviation of 1, and we will see that in a chart. In fact, here it is. So this general shape that you're seeing right here, that's what we always want to have. It is supposed to be symmetric, and it is definitely continuous data. The area under the curve is 1, and the area under the curve being 1 is because it represents all of the information that is given in the scenario, and since it is all of it is 100%, or as a decimal that would be 1. It does correspond as an area, so they might ask you for what's the area under the curve, and then we will move into what's the probability of a specific part of it. If it is a uniform distribution, what is occurring is it is the same all the way across, and so the probability of any one part of it happening is the same probability, so it is evenly distributed. It still has an area of 1, and therefore all of the probabilities add up to 100%. Here's an example. During certain time periods at JFK Airport in New York City, passengers arriving at the security checkpoint have waiting times that are uniformly distributed between 0 minutes and 5 minutes. So here's a picture of that. And so all of the waiting times are equally likely to occur. In fact, when it says P of X is 0.2, that means that 20% is for all of those, whether it's 1 minute, 2 minutes, 3, 4, or something in between. And because it is continuous data, it doesn't have to be whole numbers. It can be anything between, including that crazy number that they give as an example. If you're wondering what the number over on the left should be, if you are making your own uniform distribution, simply take the range of the data that is provided and do 1 divided by that range, and that would tell you what your probability is over on the left-hand side. So here's an example, or to continue in that example, it wants to know what is the probability that a randomly selected passenger has a waiting time of at least 2 minutes. So here's our 2-minute mark. Now at least 2 minutes means that means it's a minimum, and so they're looking at the probability that it's going to be 2 minutes or more. If each one of these sections counts as 0.2 or 20%, we have one section here, so that's 20%. Oops, we went. Okay, it needs to quit doing that. We have 20% here, and our last piece is 20%. So altogether we have a total of 20, 40, 60%. So 60% of the time they will have a waiting time of at least 2 minutes. A standard normal distribution has this bell-shaped curve. So we've got 0 is the middle, that is our mean, and each standard deviation is only 1. So moved 1, 2, 3 standard deviations, and then -1, -2, -3. Remember, negative just means it's to the left. We can find the area under that. I will show you how to do it with the table, but I also put how to do it with StatDisk on the Blackboard site. If you're using the table, remember that in a standard normal distribution, the mean is 0 and the standard deviation is 1. We have 2 pages, and I will show you both, a negative page and a positive page. It's really important that you realize that the areas or the probabilities that are given will always be to the left of the number that they are talking about. So if you are looking to the right of the number they are talking about, then you have to do an extra step and do 1 minus the data. I'll let you just read through that. Okay, here's our example. A bone marrow density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So here it is in that form. It says find the probability that this person has a bone density test score less than 1.27. So here's the table that is in your textbook. So you want to make sure you have that. So this is how it works. So we have a z-score running down the left-hand side here. These are only the whole numbers and the tenths place. Across the top is the hundredths place. So if I have a z-score of 1.27, the first thing I do is I run down to 1.2, and then I come across until I would meet where 0.7 comes down. And so here is my number, and it said it was 0.8980. So the probability of the person having a bone density score less than that is 0.8980, or 89.8%. Definitely got to figure out what's going on with that. Okay, so that's how you use that table. In the same bone density test, find the probability the randomly selected person has a result above -1. So here's the negative side. Now, just as the picture on the top shows, everything is going to be to the left, so we're going to have to do an extra step if they want it to be to the right or above. We'll first go ahead and find a z-score of -1 though. And since it was -1.00, I'm going to use the first number of 0.1587. That 0.1587 is everything below the z-score. I want everything above it. So I'm going to do 1 minus 0.1587. Which gives me 0.8413, or 84.13% of the time you will find a person who has a result above a -1. This one has where we want to find the probability of the bone density being between -1 and -2.5. So when we're trying to go between two numbers, we have to be very careful. We don't want anything below, we don't want above, we want between. So I want this area. So we're going to find actually the z-score of both of those, or those are z-scores. We're going to find the probability of both of those, and then we're going to subtract them because I need the area between them. So -1 we already knew was 0.1587. And then our other one was -2.5, so -2.50 is 0.0062. So we're going to minus 0.0062, which gives us 0.1525. So I actually wrote those wrong, I just realized, because we're doing a -2.5. This is what it would look like if it was a positive 2.5. It really should be a -2.5 and a -1, and so this is the little bit of area that it's really supposed to be showing. So this is what we found, not this. So a little over 15% of the time you will find somebody who has a probability of -1 to -2.5. So we were looking at things where they were telling us, it just like straight out in a sentence. Sometimes they'll give it to us in the form of notation. So if it's the between one, which is the last one, they'll say the probability of negative 2.5 is less than z, which is less than negative 1. We had the one where they wanted above negative 1, so that's the probability that your z is greater than negative 1. Then we had the first one, which was the probability that z was less than 1.27. We can also work the other direction where instead of giving us the z-score and asking us to find the probability, they can ask us to find, or to give us the probability or the area and ask us to find the z-score. The expression z alpha denotes the z-score with an area of alpha to its right, so this is alpha here that they're talking about. Notice that this talks about alpha being to the right. So this one says find the value of z equals 0.025 alpha is that. So now remember they just said it was to the right. So the 0.025 isn't a whole lot of information. It's not a lot of probability. So because it's a small amount to the right of the information, this is all that we're looking for. Now there's a couple ways you can do it, because remember these probabilities represent data that is below, so I could do 1 minus this and figure out what that is, but remember this is symmetric, so it's actually a little bit quicker instead. Since I'm looking for such a small amount, this tiny bit is going to be symmetric to this tiny bit over here. So I'm actually going to use the negative chart instead of the positive chart, though that way I'm looking below and I'm just going to reciprocal it or flip it over. So I'm going to look for 0.025, 0.0287, 281, forgot my number, 0.025, 268, 26, 256, 25. So this is negative 1.96. But we really don't want the negative. That's what it would look like over here. We're actually looking for the symmetric part of that. So the answer would actually be a positive 1.96. Okay, and I'll try and figure out what happened with this, and so we don't have it happen again as far as it flipping back and forth. Okay. Have a good day, and I'll get back to you with 6-2.